This lecture we are going to talk about the 8086 microprocessor and its interface with the input and output devices. We all know that the input-output systems inside each microcomputer system or a computer-based system, microprocessor-based system allows the peripheral devices or the external devices to communicate with the computer in order to send data to the microprocessor to be processed and or to receive data to receive the processed data from the microprocessor. So this communication is being done using the input-output ports. So inside the 8086 microprocessor we've got an independent memory which is dedicated for the accessing memory or those programs which are used working by communicating with the memory, and even input output address space. So inside the 8086 microprocessor, not inside it, so we can say the 8086 microprocessor can access an independent memory and input output ports as well. The memory address space is 1 megabyte, which is 1,048,576 bytes, which starts from this memory location to this memory location, which is expressed in hexadecimal, while the input output address space is consisting of 64 kilobytes, which starting from this address to this address. So the 8086 microprocessor can access a memory or it can access input output address space. Let us talk about I/O interface, input output interface. So the input output interfaces can be done or can be implemented in two ways, which are using memory, the RAM of the microprocessor, or the I/O address space, and each input or output address is called a port. So whenever we are using memory, whenever we are accessing a memory location, any location is called a memory location, but any address which belongs to input or output devices is called a port. So through the ports we can access any input or output device, and the 8086 microprocessor can access any input or output device by two ways. So the input output interface can be done in two ways. They are isolated I/O or memory mapped I/O. So these methods differ in how I/O ports are mapped into 8086 address space. You can say through those two methods the microprocessor can access any peripheral device, or they are different. They are different in the way that the microprocessor accesses any input or output device. So when the isolated I/O interfacing is used with the microprocessor, what happens? The I/O devices are treated separately from the memory. That means the memory is a standalone system, while the I/O devices are going to be connected to the microprocessor through other modules. So they are totally different from each other. So the 8086 microprocessor can do this, can access both of them. It can't access both of them simultaneously, but it can access any of them at any given time. So this can be done by the 8086 microprocessor because the software and the hardware architecture of the 8086 microprocessor supports separate memory and I/O address space. So that means the microprocessor treats the input output devices separately from the memory. When it needs to get data from the input devices, it accesses the input device, not the memory. But when it needs a data which is inside any memory location, it accesses that particular memory location. So each I/O device is assigned to a port number, which is 8-bit address range. The number of the address bits of the input or output ports is 8 bits, which starts from 00 in hexadecimal to FF in hexadecimal. So the user or the microprocessor can access any device, or can send or receive data to or from any device using in and out instructions. So whenever we are using isolated I/O interface, only those instructions can be used in order to communicate with the input and output devices. So what are the advantages of using isolated I/O interface? So in this case, when we are isolating the input and output devices to their dedicated places, so in this case, the complete memory address spaces, so all the memory locations are available for the use by memories, to be used for the memory purposes. For example, loading the programs from the disk to the RAM, or in other words, we can say the RAM or the memory is used just to hold those programs which are currently in execution, and this way we are going to have more spaces. And another advantage is that some special instructions that have been provided in the instruction set of the 8086 microprocessor, they can be executed when even not even only when the microprocessor is interfacing with the input output devices as isolated I/O interface. So those instructions can work or can be executed whenever the microprocessor is interfacing with the input and output devices using the isolated I/O interface. So, and these instructions are tailored to maximize performance. These instructions are created in order to maximize the performance of the 8086 microprocessor. So in this case, when the isolated I/O interface is used, those instructions can be executed, and in this way the performance of the microprocessor is going to be increased. But however, we've got a disadvantage of the isolated I/O. Why? Because whenever we are using isolated I/O interface, only the in and out instructions are used in order to transfer data, and those data which are transferred can be done using the AL or AX register. Whenever you are using only 8 bits, AL is used, but whenever you are using 16 bits of data transfer, AX is going to be used. So only those two registers are going to be used. This is the I/O address space where the isolated input-output interface is used, and the addresses are going to start from this location to this location, and each port can be used as an 8-bit data, okay, or 8-bit port, where only 8 bits of data can be transferred through the data bus, but two consecutive ports can be used as a 16 bits port, or a wide or a word wide port. So port 0 and 1 can be called or can be used as port 0 as 16 bits of port. So whenever you are using word wide port, what happens, this port 0 is going to be used, which is the concatenating between, or the concatenating of the port 0 and port 1, so 16 bits of data can be transferred. But when we are using only 8 bits of data, what happens, only one port is going to be used, port 0, 1, 2, 3. But whenever you are using the second words to transfer, port number 2 and port number 3 can be concatenated in order to make a single 16 bits of port. And the second type of the I/O interface is called memory mapped I/O, which is a part of the memory of, or a part of the main memory, a part of the RAM is used in order to hold the I/O ports or the address of the I/O device. That means a part of the memory is going to be dedicated to the I/O devices. For example, from this memory location to this memory location, which is going to be 4096 memory addresses, is going to be, or are going to be assigned to the I/O ports. So what are the advantages and the disadvantages of the memory mapped I/O? So the advantages are some instructions which can be used in order to modify or to transfer data inside the memory can be used to perform on the I/O operations, or to be performed on the data inside the input or output device, such as move, add, and or any arithmetic or other logical operations. So, and even the I/O transfer can take place between the input output devices and all the other registers, while in the isolated I/O only AL and AX could be used, but here any other register inside the 8086 microprocessor can be used in order to transfer data. But the disadvantage of memory mapped I/O is that part of the memory which is dedicated to the I/O devices can't be used by the memory or to work as the memory's functions, such as getting data from the memory. So they are going to be separated from the memory space. They are going to be only dedicated to the I/O purposes. Look at here, from this memory location to this memory location are called the I/O addresses. So the ports are going to be held inside those memory locations, and the functionality is going to be the same, port 0, port 1, while those two ports can be used to operate as 16 bits ports, while each of them is used in order to hold only 8 bits of data, or they can be used as 8 bits of port, while the other parts of the main memory can be used to the memory purposes. Okay, and there is something to be talking about which is called the input output handshaking. So, and we are going to take the parallel printer interface as an example, and there are 3 signals which are available in order to interface the microprocessor with the parallel printer, which are data, control, and the status. So the data signal is some parallel paths, some parallel lines which are used in order to transfer data, and the control is something which is synchronized with the data. Whenever the data is going to be transferred, the control signal must take place simultaneously, and the status means the data transfer can't take place. It can't take place if the device is not ready, so it can only take place whenever the printer is ready. Look at here. Whenever the printer is transferring the parallel printer port through the microprocessor is going to transfer the data to the printer. What happens first? It doesn't accept that data. So whenever my printer is not ready, the data is not going to be accepted. It's going to be buffered. So through this status, the printer is going to send a signal to the microprocessor to let the microprocessor know that this printer is ready or not. If it is ready, the data is going to be sent to the printer through the data bus or through the data lines whenever the control signal is going to be active. But if it's not ready, this data can't be sent. Look at this flowchart. At the first time the data is going to be sent, so before the data is going to be sent to the printer, what happens? It checks for the status. If the status of the printer is not ready, if it's not ready, what happens? It comes back again. It keeps sending data, sending the same data until it's going to be ready. So whenever it's ready through the control signal, the data is going to be transferred to the